Here is a quick response to Dr. Drjohnd1974 after his poor attempt to try and rescue his observations of Brighton from Worthing Pier. He claims I used 3 lazy assumptions. A. Using Mick West's formula. Well, I can and have recreated the formula from first principles using the assumptions that the Earth is a globe. It is a pretty simple bit of mathematics, really. To understand the second part of the formula, where refraction is allowed for, is a little trickier. But once you understand the bending of light and you use the standard refraction value, it is simple to adjust the values you use in the formula. No, not a lazy assumption. B. Using an elevation calculation that has no stated accuracy, precision, or resolution. Wow, pot calling the kettle black. The site used is a true topographical map of the area, whereas Google actually states that it is unwise to use their values for calculations as they are unreliable. Yes, I would rather have had a map which could zoom in much more, but this was used to illustrate that you cannot just use the Google values without question. Why don't you get an accurate altimeter and actually go along to the road taking measurements at each traffic light? If you had done your experiment correctly, utilizing this in the first place, you would not have to rely on Google Earth's rough values. However, just to please you, I will do calculations using a still from your video and some more accurate values from Google Earth to show you that your assumptions were really faulty. But first, have a good look at this. There is a way using Google Maps where you can use a start point and an end point and calculate the distance and elevation change from any point to another. Here I started at Mercure Hotel and ended at the Salt Room. The walk from the hotel to the Salt Room shows a gain of elevation of about 10 feet or 3 meters according to Google Maps. Wow, pretty close to what I used in my initial calculations. Here we see mostly fat, 10-foot gain, no foot drop in the whole period, starting 39 feet, ending 49 feet. What? Pretty similar to what I used, right? C. Drawing lines in the wrong place in the still from the video. My lines may not have been 100% accurate to measure a level horizon, but with the poor quality of the video and its still frame, I tried to level it using the long windows of the buildings and their roofs. You, however, then go ahead and draw your horizontal line based on the assumption that the road is perfectly flat and line up the car's headlights. Again, pot, kettle, black. Note, the poor quality of the video is not helped by the great deal of moisture in the air, which will affect the refractive index at the time. A measure of this can be seen by the size of the lights and the street lamps. These are way larger than if the air was clear. My horizontal line was there to show that the traffic lights actually varied in height above the mean sea level, a point that seems to escape your comprehension. You have not addressed the whole point of this presentation, i.e., the sea level at Brighton, as calculated, is hidden behind a wall of water, better known to flat earthers as the hump in the ocean. It also shows that the hidden amount at Brighton is virtually exactly what the refraction hidden amount calculates it to be. If you had done all the readings for barometric pressure, humidity, temperature, etc. for the whole distance this video is filmed over, a true value of the refraction could be inserted into the metabunk calculator, and I bet the results would be pretty much spot on. Why is it that when people see things a couple of feet lower than the calculator predicts, they assume that it must be broken? So, without further ado, I will present the evidence using just true Google Earth values, and the result will not change much from the initial presentation, as you're about to see. Firstly, I will show the Google Earth map with a ruler line connecting the first and last traffic lights. You can then use this to show the elevation change per Google Earth, and not to the nearest meter like when you click on a point on the surface. Note that the road is not 9 meters above sea level all the way, as used by you in your calculations. Here in Google Earth, I've drawn a ruler line from the one traffic light to the final traffic light. The elevation profile between these two marked traffic lights goes from just over 10 meters up to just under 12 meters, which proves that the road actually rises from the left to the right as I used, not stays at 9 meters like you used. This line is the direction from which you took your photo. Here is where the car headlights were approximately, just beyond the I-360 tower. Here I've taken another still from your video. There you can see the green traffic light, and there the car's headlights. The difference between the two is approximately 2 meters. So the height from there to there is approximately 2 meters. Based on that, and taking the height that is about 16.2 meters from the sea level to the traffic light, you can calculate that the sea level is approximately down here, right through the hump in the sea. This was based on the base of the traffic light only being 11 meters high, whereas it was probably closer to 12 meters high, so that the total at the top of the green traffic light was 16.2 meters. Dr. John uses about 11 meters. Conclusion. So even with crude Google Earth values, the amount hidden does not differ much from the metabunk expected value with standard refraction. There is absolutely no compelling evidence in your video to show that there is any error in Metabunk's Earth curve calculator. You have been extremely deceitful in the way you used the road height of only 9 meters all the way along the A259, or otherwise you have been totally complacent and have made a very poor attempt at this experiment. You have been debunked. P.S. I think you should go and read up on how geodetic surveys are done.